Hello. Good day, Precalculus class. We'll go ahead and get started on a new chapter. So we are finished with talking about matrices for now. Now, on your final exam, you need to remember what we've learned about matrices. But we're going to start talking about something else. In this chapter, we're going to be talking about counting, probability, and we might get into a little bit of statistics, very simple statistics. All right. I'm not sure yet. It depends how fast we go. But the first thing we're going to talk about is counting. All right. Now, counting, you might hear it and you might think, I know how to count. 1, 2, 3, 4, blah, 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 blah. And yes, I'm sure you can all count. But we are going to be learning some techniques and rules that can help us count more complicated things. Today, in this first video, I'm actually going to post 2 videos today to you guys. This first video is going to be just a quick introduction. The things that I talk about in this first video are not going to be in the homework. The homework starts from next video, but this is kind of just a basic introduction. All right. And I'll go very quickly. I hope that this video is not longer than 10 minutes. So when we're counting, we are going to be counting the number of things in some set. All right. So we use this word called set, S-E-T. All right. And a set is just basically a group of things. All right. It could be a group of numbers or items or anything like that. And we're going to be counting how many things are in a specific set. All right. When we write a set, the way we write it is we write brackets on both sides, and then we can list the things or describe the things in a set. For example, I could write A, B, C. All right, so these things are in the set, so that is a set. Or I could describe a set. I could say something like, I could write a bracket and then write all real numbers or something like that. All real numbers, and close the set. All right, so then that set contains all real numbers. All right, now we can count the number of items in a set. Now, for some sets, that's very easy. For example, here I can just say there are 1, 2, 3. 3 things in this set. There are 3 in this set. Now, in this set, all real numbers, that's a little bit more complicated. And it's actually, the answer is infinite, or it's infinity, all right? The number of all real numbers is infinite, all right? Now, when we want to write the number of things, we would put a little n in front of it, n, and then the set, and we'll say it equals 3, all right? Because that means the number of items in this set, and it equals 3. If I put an n in front of this, then the answer is going to be infinity, all right? Because the number of all real numbers is infinite. Okay, we can also give sets names. For example, I could say A equals A, B, C, and D. All right. So that means this set, A, B, C, D, is called A. And then I can just write the number of A equals 4. All right, that just means the number of things in A, which is 1, 2, 3, 4. All right, it's like that. So these are some of the ways that we might write things. All right. Another thing you need to know is something called the null set. All right. The null set is a set that is empty. All right. So if I have a set like this, and there's nothing inside of it, we call this the null set, all right? The null set, and we write it like this, all right? We write it like this. We write a 0, or a circle, and then we write a slash through it. This is called the null set, all right? All right, so these are some of the things we need to know. Another symbol that we need to know is this, all right? What is this? If I write that B, and then I write this thing, and then A, this means that set B is a subset. A subset of set A. That means the things that are in B are a part of the things that are in A. So for example, if I said A was this, all right, and then I say B is B and C, well then we know that this is true, right? B is a subset of A because all of the things that are in B and little c, are also in A. Little b and little c are up here too, all right? So that means B is a part of A. It's a subset of A, all right? In fact, we could also write B, and we can write it like that as well. This is a proper subset, all right? Proper subset, because BC is less than that. Now, if I do C and I say C is like this, A, B, C, D, well, then I can write that C is a subset of A because C contains all the things in A. It doesn't contain anything else either, and A doesn't contain any more than C, so that's why we put a line. It's kind of like the greater than or less than or equal to signs, all right? All right, C is inside of A is basically what we're saying, okay? So that's subsets. Now, let's look at this example here in our book. It says, write down all of the subsets of this, A, B, C. All right, so we have a set here. So what are all the subsets? Well, this is a subset. A, B, C is a subset of itself. All right, then we can pick A, B out. We could pick B, C out. And we could pick A, C out. All right. And then we could also just pick A, or we could just pick B, or we could just pick C, or we could pick the null set. The null set is which is empty, is also a subset of that. So these are all of the subsets of this, all right? And how many are there? 1, 2, 3, 4, 5, 6, 7, 8. All right, the number of subsets for this is 8, all right? Now, there's a rule. We can count the number of subsets, all right? So if I tell you that the number of A equals n, all right? All right? The number of A equals n, then we know that A has 2 to the n subsets, all right? So if I give you a set that has 4 in it, for example, A, B, C, D, and I ask you, how many subsets does this have? Well, the answer is going to be 2 to the 4, all right, because there are 4 here. So what is 2 to the 4? Well, that's 2 times 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8, times 2 again is 16. All right, so there are 16 subsets of this. All right, next, we're going to real quick talk about counting when we have overlapping groups. So this question here says, and when we do counting problems, the most difficult thing that you're going to see is that there's going to probably be a lot of words. It's not just going to be mathematic formulas. You're going to have to read a word problem, all right? So it says, in a survey of 100 college students, 35 of them were in algebra, 52 were in computer science 1, and 18 are in both of them, All right. So the way we draw this is something we call a Venn diagram, all right, where we say, okay, here's A, and we say A is all of the students in college algebra, right? And how many are in college algebra? 35, all right? So there are 35 students here in A, all right? Then we're going to say B is all the students in computer science. Now, how many were there? 52. So in this circle B, we know that there are 52 students. But there are some students that are in both of them, all right? How many students are in both classes? 18, all right? So we have 18 that are in both classes. Well, that means 35 minus 18, which is 17, are the students that are only in college algebra. And then 52 minus 18 is 34, which are the students that are only in computer science. All right. So we have only in college algebra, only in computer science. All right. 17 and 34. Now the question asks, how many students are registered in college algebra or computer science? They are in one of them or the other one. Or maybe they're in both. Well, we have to add all of these together. That's going to be 17 plus 18 plus 34, all right? And if you calculate that out, you're going to end up with 69, all right? So altogether, there are 69 students that are enrolled in one or both of these courses. Now, there's a way that we can do that without separating it out into groups. What we can do is we can say, well, there are 35 students in college algebra, and then there are 52 students in computer science. If we add them together, that's going to be 87, but that's too many, all right? We know that there's not 87 students in those classes because there are 18 students that are in both classes. So we counted those students twice because we counted them once here and then we counted them once here. So we counted this middle group twice. So we need to subtract them once, all right? And you get 69. All right, which is our answer. So this leads us to another rule. If we have two sets, all right, we're going to have this rule. Now, you might not know what this means. Well, n of A, and we read this upside down U, or I'm not upside down. This U shape is OR, all right? OR, all right? A or B. The number of things in A or B is always going to equal the number of things in A plus the number of things in B, then minus the number of things in A and B. All right. This upside down U thing is and. All right. So this is or and this is and. Okay. So let's look up here. So that's what this is just saying is that if we want to count all of these things, the way we do it is the number of things in A plus the number of things in B, and then we subtract the number of things that are in both of them, which is the and thing. All right, so that's going to be 35 plus 52 minus 18, and that's going to give us our final answer. That's called the counting formula. All right, we'll talk about that a little bit more. All right, we'll move down here. We'll talk about one more thing before I end this video. It's already longer than I wanted it to be. Sorry. All right, so let's look at this one. This question says we want to count the number of possible meals that we can have. Now, we're going to get an appetizer, an entree, and a dessert. So this is the thing you eat first, and then you have the big meal, which is the entree, and then the dessert afterwards, all right? There are two different appetizers, all right? Two different ones, soup or salad. You can pick one, all right? Then for entrees, you could get baked chicken, broiled beef patty, baby beef liver, or roast beef au jus, all right? How many is that? 1, 2, 3, 4. So there are 4 choices there, all right? And then for dessert, you can have ice cream or cheesecake. There are 2 choices. Now, the question then is asking how many different meals could we order? So one meal might be, oh, I want soup, baked chicken, and ice cream. Another meal might be, I want soup, roast beef, and cheesecake. All right. That's another way. Or I could do salad, beef, and ice cream. All right. There are many different combinations. How many different combinations? Well, there is a rule. All right. The rule to figuring out this out is called the multiplication principle of counting. And it tells you if we are doing a task, if we are doing something that has a sequence of choices, all right, and there are P choices for the first choice, Q choices for the second choice, R choices for the third choice, and so on, so on, so on, then the answer of how many different possible ways of doing this is going to be P times Q times R. So if we use this rule up here, well, we see that there are 2 choices for the first one, 4 choices for the second, and then 2 choices for the third. So that means how many different ways are there? 2 times 4 times 2, which is 2 times 4 is 8 times 2 is 16. So there are 16 different meals that we can make here. And that's called the multiplication principle of counting. All right, I'll stop there. We have another video.